Okay, so once we have our KSP then, we can take a look at the next part. So this time what we're doing, we're trying to find an equilibrium concentration. In this case, we start with a saturated solution and we add some KF. And if we're adding KF, we're really adding this F minus ion to it. We don't really care about the potassium here. And so even though we're adding the 0.1 mole of the fluorine, the fluoride ion, to a saturated solution, it really helps if you think about it the other way around, where if we had this initially and added a bunch of magnesium fluoride, what it would end up as. And so here's another good chance for ice. Okay, so we have two things we're concerned about. We have magnesium 2 plus, and we have the fluoride. Okay, so initially with that, we don't have any magnesium if we consider this 0.1 mole, which again, we're worried about concentration, 0.1 mole in 1 liter, it's 0.1 molar. So in this fluorine here, we'd have 0.1 molar fluoride. Okay, and so change, so if we have none of that, and we're going to add a bunch of magnesium fluoride, we're going to add some magnesium here, which we'll call this value X. Okay, we can call this value X. Then okay, so then if we know that's X, we're still going to add some fluorine in the process, and this is going to be related by our balance equation. So again, coefficient. So for each one of these we're going to get 2 F minuses. So this is going to be plus 2X. And so at equilibrium we're going to have X, and we're going to have 0.1 plus 2X. Okay? And so now with that we can put that into our KSP equation, because we solve for our value of KSP. And these X's are going to change until we get to concentrations where this solubility product equals the value that we calculated in the first problem. Okay, so we have X, and this is going to be 0.1 minus 2X squared. So even though this can be kind of confusing sometimes, so even though this is the coefficients up here are going to impact the KSP, where we're going to have to square this fluoride, it's also going to impact the X, so 2X here, because we have to take care of the coefficients as well, because it's going to be 1 to 2. Okay, and so if we do that, we're going to get this expression. We know our value of KSP, we can just plug it in later. It's just 7.09. And then if you take a look at this though, if we're having to square this value, it's going to get a little messy. And what we remember when we're doing equilibrium problems is that we can approximate something. So we're going to assume the amount of X that we're going to get here is going to be pretty negligible. Greatly simplifies this product here. So instead of having to use some quadratic equation, we're going to have X times 0.1 squared, which 0.1 squared again will just be 0.01. Okay, and if our KSP is 7.09 times 10 to the negative 9th, to find out what our X is, divide by both sides by 0.01. And our X, which is equal to, again, our magnesium concentration at equilibrium, will just be equal to 7.09 divided by 0.01, which will just be 7.09 times 10 to the negative 7th. Okay, and so that is the concentration at equilibrium.